Good morning. In this video, we are going to see the second part of engineering mechanics, dynamics. So far, we discussed about statics, where the object will be at rest when we apply a force. But here, the object will be in motion when we apply a force. So that is the major difference. Second, the dynamics is classified into two parts. One is kinematics and kinetics. In the kinematics part, the force which causes the motion is not considered. We do not consider the force, but we study only the motion. The example is, suppose if you want to see the distance covered by a particle for a particular time, where we will not consider the force, we will consider only the motion. So that kind of analysis is comes under the category of kinematics. And second category is kinetics, where the force causes the motion of the object is considered. So this is the major difference. And there are some characteristics related to the motion. Okay, and among those characteristics, we are going to pick three important parameters, that is displacement, velocity, as well as acceleration. So in this video, we are going to see in detail about these parameters only. To understand these three parameters clearly, let me take a map that is drawn in x direction, and that shows the 15 kilometers in regular interval. So now let us see a movement of the particle, and at 8 am, let me take this one as time t1, the particle is at the 4th kilometer. Let me take this one as p1, the position p1. And at 11 am, time is t2, the particle is at 10th position. Okay, let me take this one as position 2. And after that one, the particle moves back, and at 1 pm, that means the time is t3, the particle is in 6th kilometer. So this is what the distance traveled by the particle. So this is the motion of the particle. Okay, from p1 to p2 it moves in this direction, and from p2 to p3 it moves in the reverse direction. So this is the motion of the particle. Now let us study the characteristics of the motion to this movement of this particle. Now the first parameter is position p. Okay, it is the point in space occupied by a body at particular time. Okay, if you look at here, at particular time, that means at 8 am, the particle is in the 4th kilometer. Okay, now this is the position 1. So this is what here it is represented. And similarly at 11 am, the particle is in the 10th kilometer. So this is taken as p2. Okay, and similarly at 1 pm, the particle position is at 6th kilometer. So this is p3. So this is what is known as position. It is represented by the letter p. Now the next parameter is distance traveled, or distance, in bracket it is d. It is the total distance covered by the body from initial position to the final position. It is a scalar quantity. When I say initial position, p1 is the initial position and the final position is the p3. Okay, now let us go to the graph again. Here this is the initial position p1 at 8 am, and after making all the travel, finally it comes to this position. This is the final position at 1 pm. Okay, now the total distance is nothing but from this point p1 to p2, it travels around 6 kilometer. 1 2 3 4 5 6 kilometer. Then again it comes back to p3, final position, by traveling 4 kilometer. Okay, so the distance traveled by the particle is this 6 kilometer forward motion, then 4 kilometer in the backward motion. Okay, so totally 10 kilometer. So this is what here it is represented, distance between p1 to p2 plus distance between p2 to p3, and here it is 6 kilometer. It is a distance between p1 to p2, and 4 kilometer distance between p2 to p3. Finally it is 10 kilometer. The next very important parameter is displacement. It is represented by the letter S. It is the minimum distance between, it is a straight line. Just note that minimum distance as well as it is a straight line. between the initial position P1 to final position P3. Now moreover it is a vector quantity. Vector quantity. When I say vector quantity, the direction is associated with the parameters. Then finally displacement equal to S equal to shortest distance between P1 and P3. Now let us go back to the map again. So this is the position at time 8 o'clock. This is the initial position, and after making all the travel, finally this is the uh, final position of the particle at 1 p.m. Now if you look at here, initially it was in 4th position, finally it is in 6th position. So now it is displaced by only 2 kilometers from 4 to 6. So this is what is known as displacement. It is represented by dx also. So this is what is known as displacement. So here it is represented as 2 kilometer. Moreover, this is the direction of the movement, okay, from P1 to P3. Okay, so this is the displacement. So this is a two-dimensional motion where the distance between P1 and P2 is 4 kilometer in x direction, and between P2 to P3 it is in y direction of 3 kilometer. Now the total distance traveled is 4 plus 3, it is 7 kilometer. But the displacement is the minimum distance between initial and final position. So here is the straight line, okay, and this is the minimum distance, but this is a hypotenuse for this triangle. Now using Pythagoras theorem, this s can be found out like the square root of other two sides. So finally you will get the answer for displacement, it is 5 kilometer, but the total distance traveled is 7 kilometer. And moreover here is the direction, okay, this is the initial position to final position, okay, since it is a vector quantity. So the next one is speed, okay. Now let us go to the definition. It is the rate of change of distance traveled or distance, and moreover it is a scalar quantity, okay. We already know the term called distance traveled, okay, then divided by the time interval between the total distance traveled, that means from T1 to T3, okay. If you go to the distance traveled, so this is the distance traveled for the above graph, that is d equal to 10 km. So for this graph the distance traveled is from this P1 to then P2 plus P2 to P3. So total it is 10 km. Now the total time taken is from T1 to T2 plus T2 to T3. Now speed equal to distance traveled, as we discussed it is 10 km. Then the total time is between T1 to T2, then T2 to T3. It is 3 plus 2, so totally you have 5 hour. Then the speed is equal to 10 by 5, which is equal to 2 km per hour. Okay, so note that in speed we have taken distance traveled as an important parameter. And the next one is the velocity. It is represented by the letter V. If you look at the definition, it is the rate of change of displacement. Note this one, displacement. But for the speed, it is distance traveled. In the case of velocity, it is displacement. Moreover, it is a vector quantity. Okay. Now, if you look at the corresponding formula, velocity V equal to displacement divided by time interval. Here S by T. Okay, where time is nothing but is the total time between the position P1 to P3. Okay, now let us go back to the graph again. Now the displacement for this graph is 2 km. Okay, this is what we already discussed. Now let us go to the velocity, and in the place of s we just substitute 2 km, and for the total time taken, already we discussed in the previous case, that is speed, it is 5 hour. Now 2 by 5, okay, which is equal to 0.4 km per hour. But if you look at the speed, here it is 2 km per hour. Okay, for the velocity for the above case is 0.4 km per hour. Okay, note this one, velocity is equal to rate of change of displacement. It is moreover it is a vector quantity. Then the next important parameter is acceleration, and the corresponding definition is it is the rate of change of velocity. Just note here it is a velocity, rate of change of velocity. It's a vector quantity. Now if you look at the formula, A is equal to change of velocity divided by time taken, and now change of velocity can be written as final velocity minus initial velocity divided by total time taken. Now the final velocity is normally represented by the capital V, and this initial velocity is represented by small u, okay, divided by t, where t is the total time taken, okay. Now the acceleration, it is a term commonly used in our vehicle at all. When we rise or down the acceleration, the correspondingly either velocity value will be increased or it will be decreased. So to change the velocity of any vehicle, we need to give the acceleration. Okay, accelerate is a parameter which have been used in many vehicles, okay, to increase the velocity of the vehicle. So once we are thorough with the basic parameters of motion, that is displacement, velocity and acceleration, then the next one is the types of motion. Okay, there are three types of motion we normally consider. The first one is constant acceleration, where the acceleration remains constant throughout the motion. The next one is variable acceleration, in which the value a is not constant through the motion. Then final one is constant velocity, where the acceleration remains zero throughout the motion. So the movement of the object is classified into three types. Now let us go and see the very first one, very important one, constant acceleration, where the acceleration remains constant throughout the motion. You know that before going into the relationship, there are some parameters, already we discussed this, but it is needed to discuss now also. The first one is final velocity. You just look at the unit meter per second. It is denoted by the letter V, and u equal to initial velocity having the same unit meter per second. Acceleration a equal to acceleration having the unit of meter per second square. Then t equal to time, it is referred in terms of second. Then s equal to displacement, it is referred by meter. Now the relationship among all these five variables are formulated into three equations. First one is v equal to u plus at, s equal to ut plus half at square, then v square equal to u square plus 2as. So these are the three equations referred in the case of constant acceleration. Next one is variable acceleration, where the acceleration is not constant throughout the motion. Okay, let me draw two graph. One is between displacement and time, another one is velocity and time. So here is the curve in st coordinate, where the slope, so this slope, which is nothing but v equal to dsp dt. So this slope represents the velocity. Similarly, the slope in vt graph, let me take this one, is the slope, which now the slope represents the acceleration a equal to dv by dt. So in the case of variable acceleration, there are two formulas. One is v equal to ds by dt, another one is a equal to dv by dt. So now the last one is constant velocity, where the acceleration is equal to 0. Since the acceleration is 0, the above equations, that means these three equations, if I substitute a equal to 0, then you see here the final velocity equal to initial velocity. Very important data. When the acceleration is 0, the final velocity will be equal to initial velocity. Then this term will get cancelled, so you will get the displacement s equal to u into t. So velocity into time is equal to s. Similarly, if you substitute 0 for the acceleration in the last formula, which will says that the final velocity equal to initial velocity. So when acceleration is 0, you know that there are two conditions. The first one is the final velocity v will be equal to initial velocity. It's the first data. Second data is the displacement s equal to u into t, where u is nothing but the velocity, t is nothing but the time. So these are the three kind of motions normally we refer. So that's all about the types of motion. So in this video we have gone through two important things. First one is the basic parameters involved in motion. We studied position, speed, distance traveled, displacement, velocity and acceleration. Then the types of motion. There are three types of motion: constant acceleration, variable acceleration, then constant velocity. Thank you. We will meet in the next video.